Next we will begin Lab 3. Click on Figure 3-1, open in the editor, and here's the circuit. We need to click Simulate, add expressions, and go right next to the ammeter and run DC Solver. This will give me my voltage and current measurements that I want to put in for step 1. So VAB is 10 and the current is 100 milliamps. Calculate the power. The power is equal to voltage times the current. This can be found in my other lab file and you can fill that in. Then you're going to calculate the resistance. For here, you're going to use the formula power is equal to V squared over R, solved for R. And those two measurements should match. Step 5, again, calculate power. This time, for step 5, you are calculating the power in the battery instead of the 10 volts that we are measuring, which is across the lamp. We are going to use 20 volts from the source. So 20 volts, and you still will use the same current because that current, this is a series circuit, the current is the same in the circuit. Calculate the efficiency. Again, these formulas are found in the lab file. Next, you're going to pull down the file or open up the circuit, Figure 3-2. Here again, Figure 3-2, open in the editor, the circuit will appear, and this time, again, we need to get the meters working, so pick Simulate, add expressions, right next to the ammeter. Once you put that in, here the voltage is 20, run DC Solver, and we will be measuring the voltage and the current. So this 1.818, that is the voltage, and the current is 18 milliamps. The next thing they want you to do is change RL. RL is this resistor right here, so you have to click Build, right click, Edit Parameters, change it to 200. Once you change it to 200, then you can simulate again and run DC Solver. You will record these two voltages, the voltage and the current that you read. So keep following the chart and adjust all of the resistors and do the calculations. You'll find the load power, the input power, and the efficiency. The load power is just voltage times current, so you'll take VAB times IAB. If I was doing it for this problem, the 200 ohm, I would just take 3.3 and multiply it by the 16.67 milliamps. The input power, which is the next column over, that is found by using the voltage source. So instead of saying 3.3 volts times 16.67 milliamps, I would say it was 20 volts because that is what my source is, times 16.67 milliamps. Then I would take those two numbers and divide them out, P out over P in. P out is the load power, so I would take PL number divided by the input number and calculate the efficiency.